distance between them. This force is always attractive. So if there are two objects, they will always attract each other, always. And this force of attraction is depending upon two things. One is the masses itself, and second thing, distance between them. Bigger masses will have greater gravitational force, and smaller masses will have lesser gravitational force. Same way, distance between two objects being less will create more gravitational force, and distance between the object being more will create less gravitational force. We combined all and we got the formula F is equal to G m1 m2 by r square, where capital G is called as universal gravitational constant. What is the meaning of the word universal? Its importance you will realize next year, because next year you will study about Coulomb's law, where you will understand that the charge of attraction or charge of repulsion between two charges also depend upon the medium where they are kept. So the force changes if the medium is changing. So we cannot say the force of attraction or repulsion between the charges is having universal constant. That constant will depend upon the medium. But in the case of gravitation, whether you are here, whether you are on some other planet, or whether you are in some other galaxy itself, wherever you are, you will always have same capital G. Capital G is 6.67 10 to the power minus 11 Newton meter square kg power minus 2. That is called as universal gravitational constant. Then we learnt about what is the meaning of acceleration due to gravity, and I told you it is the acceleration by which any object is attracted towards a planet or celestial body. If you go to moon, with what force the moon attracts you, it will create an acceleration on you, because you know that F is equal to ma. It is called as G here. So with what force an object pulls you, it will exert a force and that will create an acceleration. So that acceleration is called as acceleration due to gravity of that planet or of that body. For example, for Earth, its value is 9.81 meter per second square. We derived the formula for it. We got the formula as small g is equal to gm by r square. Capital G is a constant, m is the mass of the planet or where you are finding the small g value. R is its radius. If you put the mass of the Earth, which is 6 into 10 to the power 24, and R of the Earth, which is 6,400 kilometers, in the formula gm by r square, you get small g value as 9.81 meter per second square. Also, if you change the place, for example, moon's mass is different from Earth's mass. Moon's radius is different from Earth's radius. It will have a different g. It is actually 1/6 of Earth's g. Same way, if you go to a heavier planet, it will have different g values. Every planet or every celestial object has its own small g. That depends upon its mass and its radius. Okay. Then we learned what are the factors that affect small g. Small g we treat as a constant. Always we take the value as 10 meter per second square. Always. But last class you have learned that it is not a constant at all. It varies by 4 factors, out of which 3 factors we learned in the class itself. One factor maybe we learned in only Sunday's class, which is not required for school. But I taught the 4th factor in the Sunday's class. Recently I have taught. So first factor was shape of the Earth. I said Earth is not a perfect sphere, rather it is spheroid or geoid. Geoid or spheroid means it is flattened at top and bottom and elongated on the sides. So this shape, geoidal shape or spheroidal shape, makes radius of the equator to be different from radius of the pole. Since the radius of equator is more than radius of the pole, the small g of equator is lesser than small g of pole. It means a person will weigh heavier on the poles and lighter on the equator, because small g is more on poles and less on equator, and small g gives the weight. Weight is equal to mg. I hope you are understanding all this. Same way, we learnt about second factor, which is the height of the Earth, height above the Earth. And we learned that as you go above the Earth, small g is reducing. How much reducing? We gave a formula for that. G dash is equal to R by R plus H the whole square into G. If you put the height value, you get the G dash value. If I ask you 2000 kilometer above the Earth's surface, what is the value of small g? You can easily say that, put the value of R, put the value of H as 2000 kilometer, and then solve, get the answer for G dash. It will be lesser than G. We also found the formula of small g if you go inside the Earth by the depth. It was surprising, but it is true that when you go inside the Earth, once again small g starts to reduce. So going above the Earth, g is reducing. Going inside the Earth, g is once again reducing because of density starts playing a role. When we were going above the Earth, density was playing no role. But when you are going inside the Earth, density plays a role in fact. So the density of the Earth being taken into account, the formula itself changes. The small g formula becomes 4 by 3 pi r rho d. And by that formula you can find what happens to g when the object is going inside the Earth. Obviously it will reduce because g is proportional to r here. R minus d actually if you go inside the Earth. So how much you go inside, that much is the value of, lesser will be the value of g. In fact, at center of the Earth, g is 0. Why is it 0? Because r is 0, g will automatically become 0. I hope you understand this. So g at the center of the Earth is 0. Is it clear to everybody? Okay. Then we learned about the fourth factor, rotation, which I not taught in the regular class. It is not there in the book also. It is there only for the competitive classes. So we will not talk about it here. Then we learned about gravitational potential, if I am right. Did we? Yes. We learned about two things, gravitational potential energy and gravitational potential. I told you gravitational potential energy is the work done to bring a unit mass from infinite to a given point in the presence of an existing mass. By using integration, we even derived in the previous class the formula for it. It's a very important derivation for the school examination. And you got the formula as u is equal to minus g m1 m2 by r. You should remember that, minus g m1 m2 by r. This is the formula for what? Gravitational potential energy. I even taught you in the last class how the questions can be asked from here. Not only here, even in 12th standard. So gravitation chapter itself is analogous to 12th standard electrostatics. So basically you are studying a lot of things about 12th now itself. So if you are good in gravitation, you are going to be good in some chapters of 12th automatically. It relates. And if you're poor in gravitation, you will have a tough time in 12th also, vice versa. So please be good in this chapter if you want to learn one chapter now itself for 12th. Okay. Then we learned about gravitational potential. Did we learn about gravitational potential also? We told gravitational potential is the work done per unit mass to bring it from infinite to a given point. Tell me, man. Yes.
Why is often getting silent and it is rising, sometimes getting silent, it is getting lower and the frequency is reducing.
Give me a second, Karthikeyan. Let me check with other people also. So, Sai Varshini, whether you are feeling the same, like my sound is not coming properly, like increasing, decreasing, something like that?
No, sir, it's clear on me.
What about you, Kirtana Rajashekar? What is your opinion about the sound quality?
Sir, it is stucky.
Your voice is stuck actually. Anyhow, fine, fine. Sivesh, what about you? What is your opinion about the sound? Whether it is fine?
It's a bit louder than usual.
It is a bit louder than normal.
It is louder than normal. Yes, sir.
Okay. Okay. Hey, that sound is going there also. This room has microphone. Careful. Okay, Shoaib Ahmad, what is your opinion? Yaar? I'll go and check my
Breaking, your voice is breaking.
breaking. Somebody is saying breaking, somebody is going louder, somebody says going lesser. We should let us see. Give me a second, guys. I'm just checking my audio. What I will check. Karthikeyan, can you just tell me whether it is fine now? Am I audible to you? What about you, Shoaib Ahmed? What do you say? Now it is okay? Okay. At any point of time, if anybody feels my voice is lagging or my voice is more louder or less louder, please let me know. I will do some changes, okay, in the sound settings. Fine, I'll continue for where I was speaking. So I was speaking about the gravitational potential. Gravitational potential is the work done per unit mass to bring a test mass from infinite to a given point. And the formula becomes V is equal to work done per unit mass. Work done already is G m1 m2 by R. So it will become Gm by R minus Gm by R. All these formula we have studied till the previous class. I think apart from that, we also learned Kepler's planetary motion. Kepler's planetary motion says that there are three laws. First law is called as law of orbits, second is called as law of area, third is called as law of time period. Law of orbit says that every planet revolve around the sun in elliptical orbits, with sun being at one of the focus. Law of area says that every planet sweeps out equal area in equal intervals of time, which means that aerial velocity is a constant. And aerial velocity is given by the formula L by 2m. How it came? I derived that day. I told you that day. Triangle taking and all these things. Check your notes. Then I talked about third law, Kepler's law of time period, which says that square of time period of any planet is proportional to cube of its semi-major axis, which is r. So if you assume the path to be circular, then the r is radius. You're eating chewing gum? Something you're eating, but or teeth you have broken and chewing teeth. Nothing is in your mouth. Sure. If you are having, swallow it. Fine then. Swallow bra kashtam. Appo enna pandrathu? Martikura, but let set the tongue. Okay. Not you, sorry, yeah. But I hope you're not eating anything. Okay. It is going live also, sorry. Don't judge me by this. Okay. Shall I continue? Okay. So, I even told you how are the questions asked from these laws. So, we'll continue from where we left. I think this is what we have studied till last class. Okay. Escape also we studied. Almost finished then. Escape velocity is the minimum velocity with which the object is projected such that it leaves the gravitational pull of the earth. I said you, whenever you throw something above against the earth's gravity, its velocity reduce, becomes zero. Then falls, becomes more. In the case you throw something with such a velocity that before it becomes zero, it leaves the earth's gravity itself, that velocity is called as escape velocity. So for that, what we need? We need the kinetic energy provided to the ball equal to the gravitational potential energy between the object and the earth. When we equate both, we get the formula of escape velocity as root of 2gm by r. Put the value of g, put the value of m, put the value of r, you get the value of escape velocity for earth as 11.2 kilometer per second or 11,200 meter per second. So that is the escape velocity of earth. It means that if you throw something against the earth's gravity at 11.2 kilometer per second, it will not come back to the earth. It will go in the space, outer space. So that's how we project things against the earth's gravity at escape velocity. Okay, up to here we have seen in the previous class. I hope most of you must be there in the class. If some of you would have not been there, I hope you would have seen the video and come for today's class. If you have not been there in the class and not seen the video also, then you can pray to the God that you understand today's class. Give the heading as orbital speed or orbital velocity, whatever you want to write. Orbital velocity. So are not comfortable in this direction, I mean, you can write. I don't have any problem. You can turn back also and write. I don't have any problem. Huh? Puriyala. Sit, do whatever you want. Orbital velocity we are talking. Yeah, please, please, please pay attention. So as the name says, it is the velocity of something in the orbit, right? So can you just tell me, Shri Krishna, something you want to say?
No, sir.
Okay. Fine, fine, fine. Kirtana, your video is off. Not Rajashekhar. S. Kirtana. Just a second. Okay, fine. Let us continue. What we were speaking? Orbital velocity. See, generally this concept of orbital velocity is used for satellites. Okay. And before I go and start talking about satellites, let me ask you, because it's a very common GK question about satellites. Okay. So I think you must be aware about that. Little bit of space if you have interest. No interest. What do you have interest? Biology. Okay. What is the difference between chromosome and ribosome? Okay, coming back. So we were talking about satellites. So anybody can tell me from online or offline people, anybody, that what are the different kinds of satellites available? There are two majority classification of satellites. What are the two major classifications? Loudly? Nah, very good. You're studying in third standard, huh? Natural satellite, artificial satellite. Natural satellite is moon. Artificial is if I throw somebody on the earth's around, it will become artificial. Yeah, please. If something lands on surface of the planet, then how can it be a satellite? You are talking about rover and something. Understood. I understood what you thought, but that is not the thing that I'm asking. I'm asking if something is revolving around a planet, it becomes satellite. As you told, that's third standard answer. Yes, moon is revolving around the earth, it is a satellite, natural satellite. And if I make something artificial to revolve around the earth, that is the artificial satellite. I accept it. I am talking about the types of artificial satellite. Any idea? No. Nah, be silent. So one satellite is called as geostationary. Geosynchronous also we called it. There are two names. One is geostationary or same geosynchronous. Second satellite is called as polar satellite. Have you heard these names? Somewhere you would have heard. Obviously, we are very near to ISRO launching site, Sriharikota. Have you ever been there? No. Pulikat Lake is very near. Go sometime if you come out of biology. So, yeah, man, it's an interesting place, man. Lake is also there. You can do boating also. Good birds will be there. And if something is launched, you can sit and clap for for something is being launched. So, coming back, what is the difference between polar satellite and geostationary satellite? Anybody has any idea?
Polar satellite means it does not revolve in
Does not revolve. So, think, try, yeah.
So geostationary satellite is the one that doesn't revolve, sir. It remains in a fixed position.
Okay, very good. And polar will revolve.
Yes, sir.
Can you imagine something goes in the space and stays in rest? Is it possible, first of all? Indumati, think about it.
It will remain in a fixed position, sir. That's what I said.
Exactly. My
Yeah,
question.
that's
So, if something goes, so this is the earth, something goes away from the earth and it remains like this without movement, is it possible? I think your thinking is coming from the word stationary. Exactly, not velocity. That's why it's called a synchronous. The satellite goes above, gets synchronized with the Earth's rotation. So as the Earth rotates, it also rotates along with the Earth. So it looks stationary for the person seeing from the Earth. We cannot see, by the way, but if you are able to understand it. By that only. Mostly the telecommunication, weather forecasting, everything happens by that only. What is geostationary? Because what we will do, if we send something above, as you are saying, Indumati, if somehow I made it stationary also, then it will not be able to capture my planet always. No, suppose I'm going above the Earth, above the India. I want to see India always, right? To check whether what movement of cloud is happening, some signal I want to send. So I want to synchronize my satellite with India, and that is only permitted also. They don't permit you to go and see all the other countries from the space. Not allowed. Understand this. So you have to go some distance above, and you have to get synchronized with the Earth's orbit. Only then you will be able to always have a look at the particular place. Suppose America is sending, America will see only America legally. Okay, so that is called as geostationary satellite. Stationary does not mean it is stationary. Stationary means it is stationary with respect to the person seeing from the Earth, but actually it is rotating only, but rotating synchronized with Earth's rotation. Is it clear, Indumati? I hope you understand what I told now. Second satellite is called as polar satellite. As the name is saying, polar. What do you think about the word polar? Beer. Loudly. Polar, that you are too much studying, man. Polar means you think polar molecules, non-polar molecules, having positive, negative centers, separated, non-polar, polar, not separated, hydrogen molecule, all these things you are thinking. Good. Polar means North Pole and South Pole, common sense. So if satellite is revolving in such a way that it is going along the poles, it is called as polar satellite. Okay, what is the benefit of that? See, it's not like it's going like this only. It can go like this also, it can go like this also, but it should move across the poles. Polar satellites are also called as low orbit satellites because their orbit is low. They have less distance from the Earth. And geostationary satellites are called as long orbit or high orbit satellites. They'll be 1,000 kilometers above the Earth and then they will rotate. Polar satellites are used for what purpose? You know why we are using polar satellites? Anybody knows why are we using polar satellites? No idea? Launch rocket. That is geostationary, I told. Weather, telecommunication, everything is by geostationary or geosynchronous. Then why are you using polar satellites? For what we want to see other parts? Mainly it is used for spying purpose. Okay? Defense you said, I not heard properly. Spy purpose means if we want to see what is happening in China today, what is happening in Pakistan today, what is happening in Sri Lanka today, neighboring countries. We don't have, we cannot go and look into some other big countries which will make it problem. But where, I am live again, sorry, I should not go out of my emotion. So whichever countries we want illegally we want to go, we can use polar satellites, but it is not legal. It is not legal. No, we have made it, but we are not allowed to see. They say that you can use polar satellites, but use only for your place. You are not allowed to go and spy. Spying is legal, you're thinking. See, geostationary is far. It cannot give you real time live things. It will give real time weather to you. It cannot see you came from your home to the center, right? It cannot track you. It can track the Earth. It can track very far, so it will not. So that's why if you see from very far, you cannot feel the vehicle is moving or people are moving. But polar satellites can see the movement also. That's why I said defense purpose. That is spying purpose. If some terrorist camps are there, people are moving, or terrorists leave, real army also. Suppose there is a war between India and China, suppose. And there are Chinese troops coming towards India. India should have a look, right, where they are coming, whether they are coming to Nathula Pass, they are coming to the Sri Lanka Pass, something. How do they? They are taking the risk. See, it's illegal. What? So you are saying that in the world only legal things are happening. Then they will respond if they have power to respond. So only 4 to 5 countries in the world have the technology to shoot down the polar satellites. Fortunately, India has that. So if somebody is sending anything to India and India detects it, it can shoot it down, allowed. So since it is illegal, if somebody is trying to spy on you, you have all the rights to shoot them down. So India also, if it sends to some country and if they catch it, they can send it down. Nothing India can do and put any case on them, because we were doing wrong only. So basically, polar satellites are used for spying purpose. So nothing from last 15 minutes we are learning fruitful. Okay, because something is, we are different on the board, and what I am talking is general knowledge for you. Actually, you should know this. Seriously, I am saying. Suppose after 10 years, 15 years, you have a small kid. He is studying in 4th, 5th, 7th, 6th standard. He comes and asks you suddenly, what is satellite? You should not blabber, no, something. So I should give the knowledge to you, right? That's why I'm teaching you. Huh? Or who gave to me? Google Perplexity and ChatGPT is 21. Huh? Okay, very good. See, man, today if you ask me one question and I start Googling or ChatGPT, what will you think about me? Will you think good about me? I don't think. I will not think good about teacher. He will, what is this? Something complex I can Google. Nothing wrong in that. But suddenly you ask, sir, what is orbital velocity? Wait, Vitambi, purpose. What is orbital velocity? If I get the answer from the AI and tell the answer to you, then what is, why I am there, man? Are you getting my point? So if your son is asking everything to you, then you cannot, this is basic thing, very basic thing. I mean, I don't support your reply that I will use all in. That means you don't want to learn this itself, then stop studying. Okay, let's not go to the debate. So, polar satellite and geostationary satellites are two different types of satellites. Now, whenever you want to set something in the orbit of a planet, for example, Earth, we want to make a satellite come into the orbit of the Earth. How do you make it? Can you think about it? From Earth, we want some object to start revolving around the Earth. How do we do it? What is the procedure for that? Send something to space. My question is, how is orbital velocity different from escape velocity? Okay. Okay, how do we do that practically?
Sir, it's projected in such a velocity that it never comes back to Earth. It just keeps revolving with it.
Something you're thinking correct only. Look, I'll give a very layman's example. Please pay attention. Suppose you are playing cricket here. I don't know which country, somewhere, maybe North America. And you are throwing a ball. I mean, definitely we cannot do on this scale, but something is thrown, it goes like this and falls down like this, right? Too much this is, but just simply saying. If you want it to fall down more farther, go little above, throw. Further down you want, go more above, throw. You want to further above, further away, go above, throw. Am I right? If I further go above and throw, it may not fall down, rather it will take the orbit of the Earth. Are you getting the layman's approach of this? So layman's approach is, if you want to project something, first you have to vertically go up, which has nothing to do with the orbital velocity. But once you reach here, with what velocity you should project, such that it does not fall down, rather it takes the orbit of the Earth, is called as orbital velocity. So basic difference between orbital velocity and escape velocity is, escape velocity is a vertical projection, whereas orbital velocity is a horizontal projection. Are you getting what I'm trying to tell? So if this is the Earth, if you make something to go vertically like this, it is escape. If you go to some height and then project something like this, it is orbital velocity. Is it clear? So write a definition of it. It is the velocity with which, it is the velocity with which, it is the velocity with which an object must be projected. It is the velocity with which An object must be projected. An object must be projected. In order to make it come in the orbit of a planet. To make it come in the orbit of the planet. To make it come in the orbit of the planet.
So, if an horizontal projects on the velocity and on orbital velocity.
Orbital velocity only. This velocity is only called orbital velocity. Are you getting my point? So if you want, I'll erase these things. You go to some height and you project with some velocity that is called as orbital velocity. It will start taking the orbit of the Earth. This velocity is called as orbital velocity. Is it clear to you? See, if you want to escape the Earth, there is escape velocity. If you want to make something come in the orbit of the Earth, that is orbital velocity. Simple. Okay? So escape is vertically projected. This is horizontally projected.
Once the object escapes, it cannot come back to Earth.
It can come back if some force is applied on that. See, many objects, like for example, satellite itself, you may think, those who know about the launch of satellites and all these things, it will have stages of separation. That is, it will have 3 boosters, fuel boosters. When it goes above, to reduce its mass, it will leave one by one. One fuel got over, it will fell down. This fuel got over, it will fell down. Finally, it will have one compartment which will be used for making it come in the orbit. So finally, it goes above, it turns like this. Some fuel remains. That fuel, they will push it horizontally to make in the orbital velocity, and then the object comes in the orbit of the Earth. Even then, they retain some fuel. Sometimes the satellites may go away from orbit. Sometimes it may go in some other direction. For controlling that from Earth itself, they have some sensors. They'll control from here. By using fuel, it may adjust itself. Usually, we will have solar panels. We'll use solar energy there. But sometimes, like for example, you asked, to make it come back, they will retain some fuel and they may make it come back, not to have it once again, to make it fall in the Nemo point. Are you aware about Nemo point? Pacific Ocean, good. Nemo point is a point in Pacific Ocean where they are dumping all the space junks. Thinking now, already we are spoiling the Earth. Yes, we are. That is a point on the ocean where all the space debris, we are making it to fall down. So if you see the point in the Google map, Google Earth, it is a point, I think almost 3000 kilometers in all directions, nothing is there. It's completely water. If you see the map, you will get fascinated. Oh my God, there is a place like this on the Earth also, where nowhere land is there. 2000 kilometers this side, all the sides, only water is there. Deepest point of the Earth is Nemo point. So that whenever they drop something, it should not affect anybody. Saving humans by spoiling the Earth. Whatever. For that, they can drop on some place itself, some population will reduce. Okay. So coming back to orbital velocity. Okay. So one thing, please pay attention, please. Shakti Varshini, your video should not go off here, please. So now think, if you want the object to attain the orbit of the Earth, don't you think that it must have the sufficient centrifugal force? I told this in the very beginning of the 11th standard itself, when I was talking about circular motion, that if any object is moving in circular motion, there is a centripetal force acting towards its center, and centripetal force must be provided by something. For example, if we talk about the movement of electron in the orbit of the atom, electron is able to take circular orbits only because of the centripetal force which is provided by the force of attraction between nucleus and the electron. Are you getting my point? If you have a stone and you are tying in a rope and you are making the rope to go like this, and your stone is able to move in circular path, it is only possible because tension of the rope is providing the necessary centripetal force for the object to remain in circular motion. So always remember, if anything is moving in circular motion, there must be centripetal force provided by something. I even taught banking off-road. I told that time to you, if vehicle is moving in the curved path, centripetal force is provided by the friction of the tire, which will make the necessary centripetal force. And whenever you have centripetal force, to balance that, we have a centrifugal force, which is a pseudo force. It is not existing, but to balance the centripetal force, we are having centrifugal force. Same value, mv square by r. So now, if this object, suppose this is the Earth, and this is the object m, which is undergoing orbital motion around the Earth, it must have a centrifugal force sufficient enough to balance the gravitational force of attraction between the Earth and the satellite. Do you agree with me? This is the gravitational force, this is the centrifugal force. I hope you understand what I am trying to say. It means that G m m, this is mass of the Earth, by, if this is the radius of the Earth r and this is the height h, then r plus h, the whole square must be equal to what? Mv square by r. So m into v square by r plus h. Do you agree with me or not? This is only orbital velocity. So r plus h will cancel this one, and we get orbital velocity as mm gets cancelled. We get root of g m by r plus h. Do you agree with me? I hope you are understanding this. Anybody has any problem in this? This is the formula of orbital velocity. Copy it down fast. This is the formula of orbital velocity, which is gme by r plus h, root of gme by r plus h. G is 6.67 10 to the power minus 11, m is the mass of the Earth, r is the radius of the Earth, and h is the height above the Earth from where you are projecting the object to come in the orbit. Shri Krishna video. Huh. This diagram. In this diagram, I have made the object to be in the orbit of the Earth like this. So, if something is moving in the orbit of the Earth, it is only possible if it has centripetal force. Who is giving? Gravitational force. And centripetal force must be balanced by centrifugal force. For balance, see, if there is only inward force, object should fall inside the Earth, no? Something should balance it in the opposite direction. Who is balancing? Centrifugal. And centrifugal force formula is given by mv square by r. So I wrote mv square by r is equal to g m1 m2 by r square. Got it? I equated both forces. In escape velocity derivation, I am equating kinetic energy and potential energy. In orbital velocity derivation, I am equating gravitational force and centrifugal force. Remember like that. Okay? Is it done? Anybody has any doubt? If anybody has any doubt, please ask me. If there is no doubt, can I proceed further? Please pay attention. So, we got the value of orbital velocity as root of g me by r plus h. Now, if h is much less than r, possible in case of what? Polar satellites. I told no that polar satellites are what satellites? Low orbit satellites, which are not much above the Earth, because they have to take the live, not just imaging. So if h is much less than r, then h can be neglected. If h is neglected, don't you think VO became root of gme by r? Because h became 0. Now this looks something very similar to escape velocity, which was root 2 gme by r. If I want to write, I can write orbital velocity is root 2 ulta I wrote. Escape velocity is root 2 times of what? Orbital velocity. Are you getting how I wrote this? I am writing here, since escape velocity is root of 2 gm by r. I hope you remember from the previous class. So if you see some place, they will write orbital velocity is equal to escape velocity by root 2. Root 2 is 1.414. Escape velocity is 11.2 kilometer per second. If you divide both, you will get approximately 7 point something. I don't remember the exact value. I think 7.6 kilometer per second. I'm not very sure about this value. It may be 7.2 also. I don't remember it, but somewhere it is 7 point something only. 7.6 kilometer per second is the orbital velocity of the Earth. It is the minimum velocity with which an object should be horizontally projected to make it come in the orbit of the Earth. So if you go to some height and then project by this distance, this velocity, then it will take the orbit of the Earth. It starts revolving around the orbit of the Earth. Is it clear to you? If yes, copy it fast. And don't forget, this is valid only for polar satellites. General formula anyhow remains the same, root GME by R plus H. Are you done? Okay.
Yes, sir.
Yes. So now we came to know about the orbital velocity of uh, any satellite which is revolving around the Earth. Now let us try to figure out what is the we can find time period. Yes, we can find. Give the heading as time period of satellites. I don't know whether these things are there in syllabus or they removed it. I'll check it anyhow. So we know that velocity is equal to displacement by time. Time will become equal to distance covered by speed, isn't it? So in the case of this orbital velocity, time will become equal to distance covered will be 2 pi r plus h. Do you agree? Divided by what is the speed? Orbital velocity. Put in the formula, t will become equal to 2 pi r plus h divided by what is the value of v naught? We don't know, root GME by r. So root of GME by root of r plus h. Do you agree with me? Guys, pay attention. You can write it anytime. You can write it even if I am not there by seeing the video. But understand the concept, please, everybody. Focus less on writing, focus more on learning. So what I did here, is this clear to everybody? For Earth, if there is a satellite, then its orbit will be obviously at r plus h distance, isn't it? So what I did here, time period will become equal to distance covered. So how much distance it covers? 2 pi r plus h divided by its velocity. Velocity is how much? Its speed. Its speed is how much? Root gm by r plus h. If you see this expression, time period will become equal to 2 pi. Can I write this as r plus h power 3 by 2? 1 by 2 plus 1 is 3 by 2 divided by root GME. Another option here. Root GME. This is the formula by which you can find time period of any satellite. One more important thing is there. Pay attention. If I square both sides, see what will happen. If you square both sides, it will become t square is equal to 4 pi square r plus h the whole cube divided by GME. Do you agree? 4 is a constant, pi is a constant, G is a constant, m of first is a constant. If I take, see, this r plus h, if I'm taking it as r, which is actually the semi-major axis, what will happen, you know? T square will become proportional to r cube. We proved Kepler's third law of motion from here. Are you understanding what happened now? So this I am taking a small r, which is actually semi-major axis. And you see here, 4 is a constant, pi is a constant, g is a constant, m is a constant. I can write t square proportional to r plus h the whole cube, which is r cube, which is Kepler's third law of planetary motion. Okay, copy this also fast.
Sir,
Hmm.
to prove on the time Kepler's third law is reportable.
Pull. Have you written this? If yes, then let us learn the last topic of this chapter. Shall we go to that? Copy fast.
So mechanics,
Mechanics?
portion sorry, the 20.
24 exam ಬರಬಹುದಾ? Okay, portion ಏನಾ?
Mechanics, gravitation.
Mechanics ಇಲ್ಲ ತಂಬಿ, mechanical properties of solids.
Mechanical solids.
Mechanics எப்படி தம்பி? See the chapter name? அந்த chapter இந்த bookல இருக்காது, volume 2ல இருக்கும். Or rotational mechanics.
No sir, ninth.
9th chapter is mechanical properties of solids. That is chapter name. Believe me, man, I am teaching for many years. Okay. That is small chapter. We'll finish it in one class. We can finish. Very small chapter. Stress, strain, Poisson's ratio, elastic modulus, bulk modulus, Young's modulus, shear modulus. Over. We'll learn soon. Today itself we'll start learning. Don't worry. It's a very small chapter, man. Don't panic. Coming back. So can I proceed further? Give the heading as energy of the satellite. Energy of the satellite. We will talk about both kinetic energy and potential energy of the satellite. And it's very simple. You understand that this is the Earth and there is mass small m moving across radius r. R is r plus h. Don't forget that. R is also can be written as r plus h. So now, what would be the gravitational potential energy? The formula says minus g m by r. Can I write like this? Any problem in this? In book, if you see r plus h, don't confuse. In book, if you see r plus h, don't confuse, because small r only is r plus h. If I ask you what is kinetic energy, what will be your answer? Half m v square. We found the value of v now. What is that? Half m. V is what? Root g m by r. V naught is root gm by r, isn't it? Or root gm by r plus h. This is the formula exactly. So I'm going to write that only. So if you square that, it will become gm by r in this case. Squared. Any problem in this? So can be written as gm by 2r. Can I write like this? I got the formula of potential energy I got the formula of kinetic energy. What will be total energy? Addition of both. This plus this will give you what? Take the LCM as 2R. This will become minus 2 G ME M plus G ME M, which will become minus G ME M by 2R. You understand this? Total energy formula, potential energy formula, and obviously kinetic energy formula. Take some space here and write. Yeah. So you got the formula for potential energy, kinetic energy, and total energy. Any problem in this? Any problem? Sure? Okay. Now if you see, before you start writing, please, Lohit Ashri, please pay attention. Before you start writing, focus here. You got the value of U as minus GMEM by R. You got the value of P as minus GMEM by 2R. And you got the value of K as GMEM by 2R. Can you say that total energy is negative of kinetic energy? Can you say that total energy is 1 by 2 times of potential energy? They will ask questions from here, for sure. They'll give kinetic energy. They'll ask you what is total energy. If kinetic energy is 100 joules, what is total energy? Minus 100 joules. If kinetic energy is 100 joules, what is potential energy? Minus 100 by 2. Sorry, not minus 100 by 2. Sorry, 2t. So it will become, you found t already, right? So multiply by 2. 200 minus 200. I'll repeat again. When the kinetic energy is 100 joule, what will be total energy? Minus 100 joule. What will be potential energy? Minus 100 multiplied by 2, minus 200. Got it? That is how they ask question in MCQ category. So please remember that total energy is negative of kinetic energy and half of potential energy. It will not only be used here, it will be used in the 12th chapter of physics named atoms. The same formula will come. Same formula. There also I will tell total energy is negative of kinetic energy and half of potential energy. Formula may change, it may become K, Q1, Q2 by R, that is possible. But the concept will remain same. So complete this fast, copy it. Have you copied? Are you done? Do it fast. Done. Careful. Right. Come fast, settle down. Now please pay attention. Before I say that this chapter is over and let us start mechanical properties of solids, which is volume 2, first chapter. Volume 1 is done now. Since we are in the halfway of the syllabus, and most of you, if not all of you, have taken exams recently in school, some of you would have got marks also. Some of you would have got very bad marks also. Why some of you? Most of you would have got very bad marks also. And some of you or no of you would have got some marks which will make you happy. Okay, so I want to talk in two terms. One, as a teacher I will speak. One, as a student I will speak. As a student means I will talk from your point of view also. So this I am saying it from the beginning of this 11th and also when you were in bridge course. I was saying very strongly that 11th is not a class like any other class in your life. Many of you who are sitting in the class, many of you, most of you have got a very good marks in 10th. 90%, 92%, 95%, 96% students are sitting in the class. Some of you have got centum in maths, centum in science. Those who are sitting here in the classroom, they are top students, I can say. Obviously, getting 95% in the board exam of 10th and struggling to pass in 12th is definitely something which you should worry about, and which parents worry too much because they start comparing directly with 10th. It's not their mistake also, because they have high expectations with you. They always think that, again, I'm live, but let me say this, that they are putting you in school. You're all studying in some good schools in Chennai. You have extra resource like this, so they are sending you to us to train you for the school exams, competitive exam. So obviously, if I am a parent also, I have expectation. My son, my daughter is going in some good school. My daughter or son is going in some good institute. Then also, where is the mark? It's a common parent mentality, and you should show no frustration for that. I know some of you will be like fighting with your parents, saying like this itself is rumba diga. Come and see in my class, nobody has passed. Don't give this kind of answers to your parents. Don't justify your low mark. You have got low mark, accept it first. And I have said this already in the past also, once again I am repeating it. When you get a paper, whether you pass, whether you fail, whether you get good or bad mark, whichever you get, make a habit of taking a photo and sending it to the respective teachers. You can send physics to me, chemistry to Ashwin sir, maths to Satish sir. But you should send. We are not sitting to judge you, man. He has failed or he has got low marks, so bad student, I'll not speak to him, I'll not see his face. Why will you do all this rubbish? Why are you feeling shy? First of all, you should not be in that mentality that I will not share. You have to share. That is the only way you can communicate to us where you are lagging. So if I say as a student, you have got a tremendous syllabus in front of you. That is reality. More than what you studied in 10th standard, much more than that. So 10th was this much small and 12th, 11th is this much big. No comparison itself. No gradual increase in the toughness. Suddenly it became very tough. And this I was warning you from very long. Some of you was taking me little seriously, and they have at least got some 60-70% marks in the recent school exams. Some of you never minded me. They would have struggled to pass. So first of all, when I am saying something, see, I am not somebody who will force you to study. You should have understood by now. Not only me, I think nobody here in Wisdom Academy will force you. We are not sitting to hold your neck and tell study, read and go. We are not doing that. We believe on educating you well and developing interest inside you for the subject. That's our belief. We always want our children to like the subject. They should learn with happiness, not with the pressure on their head. That's what we are trying to do. I don't know how much we are able to do it, but definitely we are trying for that only. So when we are lecturing here, we are trying to make things easy for you. But that is only 5% of what is really needed for you. When will you understand that? That if I teach, like today I have taught, energy I have taught, time period I have taught, orbital velocity I have taught. But until you go back to home, take 10 questions, struggle with 10 questions, you will never be able to take questions on this topic itself. Teaching is one side, practicing is another side. We are calling you for practices also, which many of you are missing. Again, I am repeating, practice class or practice worksheet that is given to you is the most important thing. I say it is more important than my class itself. My lecture is somewhere recorded, you can see it anytime. But practice class is not recorded anywhere. Until you sit and solve those questions honestly by yourself without browsing anything, you will never learn. So from your side, you should become little bit more hardworking in terms of question solving. You may have all these excuses that where I have time, where I have time. Morning I am waking up, going to school, evening coming here, then day gets over, I sleep, then time runs like that. See, you are competing with 30 to 40 lakh students of the country. Remember that 30-40 lakh students. I am saying less only, I think. 30-40 lakh students are along with you who is aiming to become good in their life. And fortunately or unfortunately, you are in India, you are born in India. You know how much opportunities you have and what is the population of the country. If we have 50,000, what do you say, trophies, we have 50 lakh people fighting for it. So you have to be in the best 50,000 students. See, I am not advertising anything here. Don't think I am trying to make you interested towards NEET or JEE, nothing like that. Do good in school itself. Nothing, no problem in that. It's not like only IITians are flourishing in their life. There are many people who are doing very good in their life. At least they are good in what they are doing. So first of all, understand you are not competing a small group of people here. Don't see your classroom, don't see your city, don't see your state. You are competing in the entire country. And if you really want to do something good in your life, if you don't want to be depending upon your parents' assets and parents' money, then you should start taking things seriously. I do understand this is the age of all deviations, where all rubbish will come to your mind. I don't want to speak about that, but it is true. This is the age where every wrong thing will come to you somehow. The person who is overcoming that wrong things and able to focus in their studies, they will rise up. One who gets trapped in all these friendship, social media, unwanted talks, unwanted things, they are going to go down only. Nobody can save them. Just because you are going to good school, you are coming here, your marks will not improve. Marks will improve only if you take this as a challenge, not as a burden. Again, I am repeating, even I have crossed your age, and there are so many students who are crossing your age now along with you. And there are so many students who are doing really good because they are managing their time well. Like you, they also have all these things, school, coaching, this thing. Everybody has that. You cannot say I only have that. But it's your duty to take out time from there. Wake up early in the morning. After you come back, take out 2 hours of time before you come here. If you don't have time like that, then after going from here, take out 1 or 2 hours for studying. Now, how you are going to do it, I cannot talk generally about it because everybody has different school time, everybody has different weekend plans. I cannot make a plan for you generally. Why I cannot make? Because some of you are coming home at 5:30 p.m. Some of you are coming at 3:30 p.m. Some of you are coming at 6 p.m. also. So how can I give a generalized plan to you? I cannot give, unfortunately. But I can obviously say that don't think you are the only one who is undergoing this. Everybody undergoes this when they are in 11th standard. If you give up, you will go down. If you learn from the mistakes that you have made, accept your failure, you will rise up. Now, after this, the next exam that is going to happen, how will you perform? How will you change your name in front of your parents? That is your responsibility. What support you need, we will do. But we cannot go and write exam for you. How many times I have told this? What I can do is, some doubts is there, come, I will teach you. I will make it easy for you. I will solve 10 questions along with you. These things I can do. But I cannot go and write exam on your behalf, isn't it? And I saw question papers this time. That day I discussed with you also your question paper. Believe me, Alvin's school question paper, I saw and I detailedly saw all the questions. It was damn easy. It was damn easy. All the Alvin students, I think whom I remember is kind of Manager or Sai Varshini. Sai Varshini's marks I got through your mom. Manager marks I don't know. And I think whoever else is from Alvin. I think Sivesh also is from Alvin, isn't it? If I am right. Tomorrow you say yes.
No, tomorrow there.
You are from Alvin, right, Sivesh?
No, sir.
Which school you are, man?
Zion.
Zion, Alvin is same for me, man. Don't say Zion and all. What is this? First you mute yourself, please. So, I think Zion will have same question paper as Alvin. No, he is CBSE only. No,
I don't know, sir.
you don't know, but it is true. Believe me.
Okay, sir.
Okay. So, your school paper I saw. Mute yourself, please. So, I saw your paper. And I don't know how much marks you have got. I'll know it tomorrow when you come to meet me. I think your mom would have told you. I have called you to meet me tomorrow. If she not told you, I'm telling you now. So, you cannot justify that I lost marks because this, because of that. Everything was simple. Everything was simple. SSM tomorrow distribution of paper, right? Yes, let us see. So, guys, become serious, please. For the sake of syllabus finishing, I am keep on moving only. But don't make it like school, coming here, passing time and going. Learn from here and apply in some questions, practice it. Until you take all the practice things seriously, it will not work out. Whatever worksheets I've given to you till now, you have to make sure that everything you have done by yourself, not by mugging up. Doubt is there, ask the respective faculty. Alamalu ma'am is there, I am there. Whenever you want, you can meet us. I am not seeing anybody approaching us for any doubts. Very few are there. It means that you are not studying. Because if you are studying, doubts will definitely come. Nobody can say doubt. Then you are school topper. Nobody is there like that. So please, guys, wake up now, or else what will happen? I'll tell you. You will lose interest. This only will happen. You will accept that my capability is this much only. 60% marks on the podum. This is only my caliber. Before that happens to you, your psychology gets disturbed, and you start accepting the defeat. And you start, this is only my caliber. I will not go beyond that. It will happen, guys. You may be your 96% in 10th, but you will be happy with 70% marks. It may happen to you. Your psychology will become like that. Don't let it happen. Still aim for 90%. Work hard for that. Because the biggest problem is when you enter from 11th to 12th, if you go with a poor psychology, it will affect your 12th performance also. And if I talk about physics, because I am knowing that very well, 12th physics is 50% of 11th physics. That much simple it is. So it helps you because you are getting trained in 11th itself to face that 12th easily. But again, if you go with a very poor score in 11th, how much ever good you are, you will always get satisfied with less marks because you would have got only 60% in 11th, and when you go to 12th, you get 70%, you will be happy. Yeah, enough. Don't come in that category, please. Again, I'm saying before I start next chapter that I know you all are facing tough time. I'm not denying that. I'm not saying you are enjoying, you are not studying, you are playing too much. Nothing I'm saying. I know everybody who's sitting here, everybody sitting here is somehow working only. But you also understand that your hard work is not giving sufficient result. And in that case, you have to sit and find ways how to improve your marks, how to improve your performance. For that, if you need our help, come to us, that I can talk separately to you individually. Because I thought I cannot give general plan, but I can give plan for a particular student, because you can tell me, sir, this time I'm coming, this time I'm waking up, this time I'm sleeping. So I can make a plan for you. That much help I can do for you. But more than getting a plan from me, why don't you do it by yourself? Because you know yourself better. Moreover, one thing I will say, that make sure that every day you touch every subject. Half an hour itself, but do. Like, it's not like 2 days I will study math, 2 days chemistry, 2 days physics. You will forget things. Every day I will study half an hour physics, half an hour chemistry, half an hour, whatever happens, I will study. It will help you. Believe me, it will help you. You solve 3 questions only in every day. But 3 questions solving every day from physics and then going to chemistry, then going to math, it will retain in your memory better. So now everybody who have taken their exams recently and going to start appearing for the next examination, check your syllabus, like how he told that in my next exam we have gravitation and solids. You also should know what is going to happen next in your school and start working for that now itself. Next exam happens, get good marks. You be happy, your parents will be double happy. That will give some positivity around you. Once again, next exam happens, you get low marks, so it will create negativity in your mind. That is not good for you. Please listen to me and follow what I say. We are very liberal. We are very, what do you say, kind of friendly with you. Does not mean that you should behave to us like friends. We are giving that space to you so that you can come with your problems to us. We don't want to become like school teachers that we don't go and talk itself. We are maintaining some closeness with you because we want you to be open to us. Don't hesitate. Come and meet us. Clear your problems. Use this opportunity, because many are there who are not getting any opportunity. You are privileged. Seriously, I'm saying, you are privileged. See the people around you. There are so many people who want to learn but not able to learn because of no facilities available to them. You people are having all the facilities available to you. You are misusing it. So wake up, work hard, work very, very hard, manage your time well, and then you will see a good result in the next time. Okay? I am convincing myself actually for your poor performance. That's the reality. And once again, I'm saying, everybody make a habit of sharing the paper when you get it in your hand. Not the marks alone, the paper. Take a photo of it. If you are not able to bring it here, take a photo of it, share with me. I will have a look at each page, how you wrote, what wrong you made. And make sure when you share the paper with me, share the question paper also. Because I am not magician, I cannot know what question came. You not wrote the answer itself. So you should share the question paper along with the answer, or if possible, bring the paper to the class. After the class gets over, before the class starts, come and discuss the paper with us. Please start doing all this and give the heading as mechanical properties of solids. Mechanical properties of solids. It is the next chapter. Chapter number 9, if I am right, isn't it? Okay. So if I give you a brief about how your volume 2 is going to go. Volume 2 means this second volume of the physics. In this volume, you are going to learn about properties of solids and fluids. Some of you, if you are wondering where is the gas, why only solids and fluids? People are illiterate enough to not know that fluid means liquid as well as gases. I know some of you are not thinking this. Don't act over smart. When you hear the word fluids, many think it is only liquid, because from our childhood we are using fluid only for liquid. We rarely use it for gases. So we think fluid means liquid. It's not like that. Fluid means anything that flows, which includes gases and liquids. So you are going to study about solids and fluids, their mechanical properties and thermal properties. The first chapter teaches you about mechanical property of solids. Second chapter will teach you about mechanical property of fluids. Then you will learn about thermal properties of matter, all the three. And then you will learn about thermodynamics, which is there in chemistry also. But physics thermodynamics will be a little different from chemistry. I think it is a little easier. I don't know how you will think. So some thermodynamics will come, where you will learn about laws of thermodynamics, zeroth law, first law, second law. You will learn about how engines were being made, how to calculate its efficiency, all these things. And then you have a small chapter called as kinetic theory of gases, KTG, kinetic theory of gases, where you will understand about how gases behave, their pressure exerted on the surface, how to find degree of freedom, how to understand how energy is being imparted in the gaseous state. Small chapter, one day only, it will be very small chapter. Then we will go to the last two chapters, very different from all these things, very different. Waves and oscillations. I think some schools have taught this chapter itself, if I am right. Some schools, they taught this chapter in the beginning itself. Whatever. We will learn here waves and oscillations at the last. Okay. This is going to be the volume 2, the chapter list. Today let us start with mechanical properties of solids. So if you are wondering why are we learning even this, what will happen by this, then let me tell you, this chapter is the base of everything around you. That is, if you see a board in front of you, board in the sense it is a kind of panel, flat panel, TV you can say, simple layman's word. This TV is made up of some materials, some kind of plastic may be there, some kind of metal may be there, some kind of glass may be there, isn't it? This chair is made up of plastic. This camera is made up of some lenses, some kind of plastic again, some kind of metals inside. AC is made up of something. So whatever things you have around you, it is made up of some materials, right? Some solid materials. Those materials, how are they chosen? If I make aeroplane, I will use some of the alloys of aluminium. How did we decide that? If I am going to make this kind of wall, I am going to use only bricks, I am going to use concrete. If I am going to make a chair, I am going to use this material. How do we decide that? You never bother about it. It's there, I will use it. Experiments, obviously, yes. But experiments to find what? Its properties, mechanical properties. It's not only physical properties, durability, obviously. All these things comes under mechanical properties. So once we know how this material behaves, we can choose it for the required purpose. It's a small single chapter for you. If you go to civil engineering or mechanical engineering in engineering, this topic comes for 3 semesters, 1.5 years, this one chapter. 3 semesters it is being taught. That much important this chapter is. But for you it is small, simple, less weightage chapter. But its importance is huge in the future. If at all you take engineering by mistakenly or forcibly or your interest, then you will be able to learn all these things about solids and its properties. Okay? This topic starts with the first understanding of the word elasticity. Elasticity. And I would like to ask this. I'll ask to Shoaib Ahmed. Will you tell me what is the meaning of the word elasticity? You may be right or wrong. Give a try. What is elasticity?
Well, how much the object can be expanded.
Good. How much the object can be expanded. Okay. So Lohita Shri, can you unmute yourself?
Yes, sir.
Yes. So what is your opinion about elasticity word? What do you mean by elasticity? Elastic.
Stretchable, which is easy to stretch.
Easy to stretch. Okay. Lakshita Shri, do you agree with this? Lakshita, if you're hearing me.
Yes, sir.
You agree with what she told? Did you even hear what she told?
Yes, sir.
Okay. Now I'll ask a question to you, Lakshita. You just tell me the answer for that. Okay. Question is, they said, even Shoaib and as well as Lohita, they both said that elasticity means how much a body can stretch, how much it can expand. So I'm giving you two materials. I'm giving you aluminium and I'm giving you rubber. Aluminium and rubber. Which is more elastic, aluminium or rubber?
Rubber.
Obviously, yes. Menaja, what is your opinion? Rubber or aluminium?
Rubber.
Okay. Harin Krish, what is your opinion? I am waiting for somebody to say aluminium. I'll come back to you. Then I'll take your class. Yes, Indumati, what is your opinion?
Sir, rubber.
Anybody says aluminium? Online people, leave offline. Online people, anybody says aluminium? So can I take everybody says rubber? Okay, I took it. In this classroom, except Mr. Lalit Ramana, anybody says it is aluminium? It's much safe you are playing. Yes, Mr. Lalit. Lalit Ramana here sitting in the class says that aluminium is more elastic. Give me an explanation for this answer, man. He told something which is not wrong. Answer is aluminium. But you're not told. So not accepted. Until you say, you should be bold enough like Lalit to say boldly, yes sir, aluminium. How much ever I tried to shake him, he not shaked. What? Good man, I appreciate. So, how is aluminium more elastic than rubber? It is very difficult for our brain to process it. Because once again, from our childhood, elastic word we are using for something which is stretchable, like how Shoaib told, how Lohita told. Generally, when we hear the word elastic, what we understand? Stretching something is elastic, rubber band elastic, isn't it? Immediately what comes to your mind is some kind of rubber band, some clothes which can be expanded like this, some elastic that band. That only comes to our mind. But what is the real meaning of elasticity? Write the definition first. Please write it down. Seriously, na first na. Definition is, it is a property of the material. It is the property of the material. It is the property of the material to regain its original shape and size. To regain its original shape and size. To regain its original shape and size after the removal of deforming force. After the removal of deforming force. After the removal of deforming force. Now in this definition, one new word is there, deforming force. What is the meaning of that? Yeah, any force which can change the shape or size of the object is called as deforming force. So imagine you have a bar made up of aluminium and you have a bar made up of rubber. I hang 5 kg box here and I hang same 5 kg box here. What will happen? Rubber will something like a sag, right? It may sag a bit, not visible much. Sagging is not elasticity. Elasticity is when you remove this 5 kg, whether the object is capable of going back, that is on elasticity. This rubber may go back, may. 5 kg is there, no? This will definitely go back, aluminum. If I make this 5 kg, 50 kg, what will happen? Rubber will get permanently stretched if it is strong rubber. If I remove also, it may little go back but not go back completely. Am I right? But aluminum may go back or definitely go back more than rubber. If I put 150 kg, it may break itself. It may bend a bit, but it may little bit go back from the position. Now tell me, which material out of these two have more tendency to regain its original shape after the removal of deforming force? Obviously aluminum. That makes aluminum more elastic than rubber. So understand from today, elasticity is not only about something being stretched. Elasticity is all about object regaining its position after the removal of deforming force. Is it clear to you? Next you write plasticity. Ulta of this, plasticity. And you write a definition, what will you write? Exactly. It is the property of a material by which it does not regain its original shape. It does not regain its original shape after the removal of deforming force. After the removal of deforming force. To make it a little more simple and layman's language, I'll use one more example. Most of you would have seen your mother cooking, father cooking, whoever cooks in your home. So when they are cooking, I'm talking if they are cooking some kind of roti or barota, whatever, if they cook in home, then the way the before I say it, start laughing. Okay, man. So for making chapati, there is roti, we use godumao, right? Mostly. And for making barota, we use maida mau. Am I right? Have you seen that both the maus, whether it is godumao or maida mau, they don't behave same way? Have you felt it? Yeah, it is elastic actually. Whereas what is godumao? It's plastic. Don't go and say to your mother. Okay. So maida's behavior is more plastic actually. That's the reality. If you take godumao and stretch it, it will stay in the same place. Take maida mau, stretch it, it will try to go back at least. It may not be able to fully go back. That's why it is difficult to make parota, yeah? Because we are stretching it, it will once again become small. Once again stretch, it will once again become small. That is a property. That property is called as what property? Elastic property. And godumau's property, you take, easily you can roll it and make chapati. Easily means difficult to make circular shape, but easy to at least stretch it. Whatever shape you get, Tamil Nadu or Kerala. But something will come if you roll it. But if Kerala eppadi varuma? First you understand what I'm saying. Okay. I said mouse shape, man. So when you are trying to make a shape of maida, it will be difficult because it's having elastic nature. But when you are trying to make something with wheat dough, it will be difficult to make. It will be easy to make because it is more plastic in nature. I hope now you will remember what is the meaning of elastic, what is the meaning of plastic, at least now. Okay, fine. Now, in this chapter, the main thing which starts is learning about stress and strain. Give the heading as stress. Give the heading as stress. And let me ask Madhuvanti, if I am taking your name correctly. Yes, Madhuvanti. What is stress? What you are giving to me is stress. What is stress? Tell me fast. What you know, you tell. It's right or wrong is not a problem. In your school, they not taught this topic still now, no? So I'm not expecting a correct answer from you. Say something. Something like pressure. Okay, fine. Chaitanya, in your school, they taught this chapter? Anyhow, tell me what you know.
No idea. Same thing. Like
Anybody from Sriniketan here? They taught this chapter, no? They have not reached, for you finished, right? For you, they have not taught stress. Stress they would have taught. Then tell what is stress. Was before you. So she more remember, they recently taught, she should remember more. What is this? If you tell, sorry, it was taught before 1 month, so I don't remember. So recently taught, so I don't remember. What is this? Now she made statement changed. Enough. Yes. Good. Raghav says that force applied per unit area is called as stress. I agree with you. Then I'll ask you, what is pressure? It is also force applied per unit area. So pressure is equal to stress? Yes, sir. Dimensions are equal, I know. Huh? Did I ask dimensionally equal? I asked they are same or not. You said yes, and you are wrong. See, remember Newton's third law of motion. To every action there is an equal and opposite reaction. If I am having my hand held here, wait man, time is over. If I apply a force, why my hand is not going down? Because my hand is also applying a force. Restoring is not a correct word, resisting force. Because my hand is resisting the force given by the pen, it is not going down. Am I right? So action is applied force, reaction is resistive force. Applied force per unit area is called as pressure. Resistive force per unit area is called as stress. Write the definition, please. Resistive force per unit area is called as stress. Resistive force per unit area is called as stress. So what will be its unit? Obviously, no doubt, Newton per meter square. What will be its dimension? ml power minus 1, p power minus 2. Okay. Now, write one more statement. Stress is intrinsic property of a body. Stress is what property? Intrinsic. Intrinsic property of the body. Stress is sorry, intrinsic property of the body. Okay, now please pay attention. Intrinsic. What is the meaning of that? It means it is the material's property. You cannot give stress. You can give only pressure. Stress will be taken by the body itself. Like I can give pressure on you. I cannot give stress to you. You will get stressed. In general English also, we never say that, why are you giving stress to me? If you are saying like that, then your English is poor. You should not say, why are you giving stress to me? You should say, why are you pressurizing me? I am getting stressed. I am getting stressed. I hope you are getting what I am trying to say. Stress is intrinsic property. You cannot give stress. You can give only force, pressure. But the body will develop stress. Is it clear? Hopefully. Okay. Stress is basically, there are so many ways I can classify stress. But, tell me Raghav, what you are saying. I will not classify in that way. You can say lateral stress, longitudinal stress also, but I will classify in different way. I will classify like solid stress, liquid stress. Man, it is normal stress and shear stress. Okay. Time is going closing 9. People are starting to drop. Let him speak. I will go. Okay. Fine. Thanks. So normal stress. Normal stress means if there is an object and you are applying a force normally to it, perpendicularly to it. It can be a tensile stress like this where the body is getting pulled, or it can be a compressive stress where the body is getting pushed. These kind of stresses where the applied force is perpendicular to the surface is known as normal stress. Are you getting my point? If there is an object, I am trying to pull it like this, it is normal stress. If I am pushing it like this, it is normal stress. Normal stress in the body because the force is applied perpendicular to the surface. Is it clear? Another thing is possible. What is that? If there is an object and if I apply the force only on its top layer, something you can imagine like notebook is kept and I apply a force only on this surface like this. Sorry. So when I apply a force, you can see that the object may, sorry, yes, the object may bend like this. Isn't it? This kind of stress is called as shear stress. In shear stress, the object gets sheared, kind of slipping. It is also called as tangential stress because the force is applied tangentially on the surface. Are you getting my point? Shear stress na on the object. Suppose this is the object. If I apply a force on the surface, okay, that time whatever stress is developed inside the body, that stress is called as shear stress. So in shear stress, the force is applied tangentially. In normal, it is applied perpendicularly. Are you getting my point? Now this can, like how you say, like how he told, it can be classified as tensile stress. It can be classified as compressive stress. I'll talk about longitudinal also. For many time, long time you are saying the word longitudinal. I'll explain you now. So if you have an object like this, 3-dimension, okay, and if you apply a force like this, tensile normal force, isn't it? What will happen? The body becomes longer. At the same time, for conserving the volume, the body will become thinner also. Don't you agree with me, Raghav? The body not only becomes long, it also becomes thin. That time the stress developed in the length is called as longitudinal stress. And what is the stress developed across width? It is called as lateral stress. If I have this pen, if I stretch it, it will become long. So stress force acting per unit area in this direction is called as longitudinal stress. In this direction, lateral. Okay. So I am not classifying in this way because not required now. So basic classification only two: normal, shear. In normal, the force should act perpendicular. In shear, the force should act tangential. Draw this, please. Copy it fast.
Sir, vertical force pressure lateral.
Purila, திருப்பி
Vertical force pressure lateral.
திருப்பி.
Lateral system vertical.
No, lateral means, see, this is the object, no? This is called as longitudinal length. This is called as lateral. If this you are taking as lateral, longitudinal, this will become lateral. Are you getting a point? Any object will have two dimensions. One is longitudinal, one is lateral. If I apply the force like this, it is longitudinal. This will become lateral. So longitudinal is getting long, lateral is getting thin. If I compress it, then this will become longitudinal, this will become lateral. So if longitudinal is reducing, lateral is increasing, and vice versa. If longitudinal is increasing, lateral will be reducing. Got it? I'll just take the attendance. So Meneja, can you unmute yourself?
Yes, sir.
So were you able to hear me for the class? Like it was fine, it was audible?
Yes, sir.
There is no issue in the hearing, right?
No problem, sir.
Okay. So what about you, Kirtana? You were able to hear me properly today? I'm just getting a feedback because mic whether it is working fine or not.
Yes, sir.
Okay, fine. Anybody who faced trouble with the class today, like hearing the noise or something like that? Obviously, you people will not. Yeah, nobody, right? Okay. In that case, those who have finished copying can drop. Good night. We'll meet again in the next class.
Thank you, sir.
Take care. Take care. Take care.
Thanks.